So this presentation is by Gregor Scheipl from JOANNEUM Research. He's joined us from Austria, and he'll be telling us about roll-to-roll nano imprint lithography for really highly innovative use cases. So we started about 1 minute, just waiting for the audience to come. Yeah. So while I have your attention again, let me do a quick promo. We have this event on site in Eindhoven. Really exciting event, fantastic location, very high-tech location. The exhibition floor is pretty much sold out, and there is a lot of demand for the visitors. So please secure a space as soon as you can. Gregor, the stage is yours. You can begin.
So yeah, thank you very much for the opportunity to give a talk here. A short introduction of what we're doing in the field of roll-to-roll UV nano imprinting lithography. So JOANNEUM Research located in Austria, and to wrap it up, we have one vision with this process: from nano goes macro. So I don't know if all of you are familiar with UV nano imprint, and so we have the ability to produce very small structures on large scale, so on large and mechanically flexible substrates. In the first step, we have to apply a coating, a resin. Then the next step is the molding, so giving the coating the structures and the subsequent curing via UV, and then the demolding, and finally you have the structure. So it seems to be quite a simple process for highly complex and very small structures. And what we have established over the last decade at JOANNEUM Research is a so-called patterning pilot line, where we start with a material. So we develop our own material, which is a NIL cure. It's like polyurethane or acrylates, which we can adjust to the specific needs a little bit later on. Then we have the simulation and the design by software tools to identify the optimal structure. Then we make the mastering, so with, for example, MALA, so maskless laser lithography, and the upscaling from the master by step and repeat to really have a full shim equipped with those structures. And we can do polymer shims on our own at JOANNEUM. And for nickel shims, we have partners in-house due to the fact that we don't do this metallization by ourselves. And finally, you have the production. And so this NIL cure resins, this is a registered trademark of JOANNEUM. And on the video below, you see that we can really turn it and tune it in the field of surface energy, refractive index, elasticity. They are currently 70% bio-based already. And I'm going to restart this video. As you see with a needle, for example, you have with a standard resin, you have really scratches and all this. And by adjusting our material, it perfectly fits the desired need. And so the pilot line on the right-hand side, we have this maskless laser or e-beam lithography for origination. Then we can make the tooling and mastering by this step and repeat, so to scale the small design up for the whole shim. Then the replication, and finally, of course, the printing like 2 to 2.5D for microfluidics, micro-optical structures, or bionic structures like riblets, moth-eye, or lotus, which is shown here, some applications. Bionic films, for example, is drag reduction, where we mimic the shark skin. So to reduce drag, if you glue this foil on airplanes, like Red Bull Air Race is equipped with those foils, it can result in fuel reduction, drag reduction, for example, planes or ships. Then freeform micro-optical films for also medical diagnostics, but also for lighting industry. Microfluidic films are very interesting now in the field of lab-on-foil and lab-on-chip systems. We can enhance the surface for decorative films, but also create plasmonic films or like metal mesh, highly transparent conductive films. And here are some examples and enlargement of the picture shown before. This is realized by pilot line or open innovation testbed projects. which we currently participate or coordinate, like Fabulous, MedFab, Flex Function to Sustain. And so in the picture right below, for example, this is a new picture. It's a holographic structure on a recycled bed with a biodegradable resin for security features like for banknotes, for labels, or also for tickets. And if you're interested in those projects, you can apply for microgrants, but we can discuss this later on. And last but not least, another result from next-gen microfluidics, like this is a microfluidic channel shown in the left video with pillar arrays, where the liquid perfectly distributes. So for oil and lab on chip systems, and for example, if you need some other structures, when you don't have these capillary effects, so triangles with channels in between, and you see when you drop some fluid, you have perfectly smooth distribution of the liquid. And so here the material, the design, and the production, of course, are very, very important. And I think that we at JOANNEUM Research have along the whole value chain, profound knowledge, which we like to offer interested companies. And so, yeah, I thank you for your interest.
Thank you so much.
And I'm done.
Thank you very much, Gregor.